Welcome to the last unit of the Fundamentals of Algebra course. And I am actually very excited for all of you because this unit is algebra content. So this unit is the transition from pre-algebra to algebra. So the idea of this unit is just to introduce you into some algebra skills that will help you in the future if you ever take any algebra courses, and to also help you grasp some different ideas. So this unit is all about something called polynomials, and we'll get into what exactly a polynomial is here in a little bit. But we're going to be doing order of operations with polynomials. Is essentially what this unit is about. So without further ado, let's get started with our first topic. And our first topic is about exponents. Now, we've done stuff with exponents in the past, for example, like 4 squared or 3 cubed, right? We know what that is. We know what that means. But now we are going to take a little bit of a spin with exponents. So we have done a lot with linear equations. In Unit 6, remember, we learned how to solve all kinds of linear equations, like 3x plus 6 equals 0, or we learned some more, time-consuming equations where we did the linear equations with fractions and all these kinds of things. But now we're going to transition from linear equations to things that aren't linear anymore. So remember, something that's not a linear equation could be something like 3x squared plus 2x plus 3, right? And we can set that equal to 0. Let's just say, for example, this equation here, this is not a linear equation because of this x squared term. So this is kind of what we're getting into. So before we start doing operations, though, with equations like this, we need to understand some basic exponent rules. So displayed below, which is here, are some exponent rules. So we first have this 0 rule, and this 0 rule basically states that if we have anything raised to the power of 0, that will always equal 1. Always, always, always. Anytime you have something raised to the 0th power, or to the power of 0, it will always equal 1. And then our next rule is the product rule. So if we have something raised to a power times another thing raised to a power, we can add those two exponents together. However, one thing you need to be very careful about is notice that this here is an x and this here is also an x. So what that means is that this whatever we happen to be combining these exponents with, they need to have the same base. So these x's here, they are resembling what is called a base. Now this base needs to be the same. So if we were to have, for example, or here, it's kind of messy. So let's say if we were to have x to the 3rd power times x to the 4th power, we can combine those exponents together because they have the same base, because these both are an x. But if we were to have something like x cubed times y to the 4th, we cannot combine those exponents. So this does not equal x to the y 3 plus 4. So notice the difference, right? So we need to have the same bases to be able to combine these exponents. X to the third times y to the fourth does not equal this. And if you're interested what it is, x to the third times y to the fourth is just x to the third times y to the fourth. That's all it is. We can't really do anything with that. But anyways, moving on to the power rule, if we were to have something with an exponent and we were having that being multiplied, or this entire thing being multiplied by another exponent, or this entire thing being raised to another exponent, instead of adding the exponents, we're going to multiply them. And then last but not least, we have the quotient rule, which is when we're dividing exponents. So if we have the same base, like we need to have with the product rule, then we can just simply subtract those two exponents and keep that base. Now, let's dive into our first example. So I encourage you to pause the video and try these first 4 examples on your own, using these rules I just walked through. So now let's get into it. So we have 3 squared times 3 to the third. Now, if you use order operations and did exponents first, and then multiplied, and then fully simplified, that is correct. That is a correct way to solve this. However, I am going to rewrite this using these exponent rules up here, because you can also use these exponent rules as well as order of operations. So either way works, but I'm kind of just introducing us into this idea of algebra rules. So we have 3 squared times 3 to the third power, which is 3, which our base is the same. We have 3's. So we're going to do 3 raised to the 2 plus 3 power, which that is 3 to the 5th power. And I'm not going to expand that out because we know how to evaluate 3 to the 5th power. So for our second problem, we have 3 squared all raised to the 3rd power. So because of our exponent rules, we can say that we're going to do 3 squared times 3. Now this comes from this power rule right here. So using that power rule, we're going to do 3 and then put this in parentheses. So we get 3 raised to 2 times 3 is 6. And that is our final answer. Looking at example 3, we have 3 cubed divided by 3 squared. So since we have the same base, since our 3's are the same, we can just say 3, and then using this quotient rule here, we're going to subtract our exponents. So we're going to have 3 raised to the 3rd power minus 2. So this is going to become 3 to the 1st power, which is just 3. And then for example 4, we are no longer dealing with integers or numbers. We are now dealing with variables or letters. So we're going to use the same exact process. But the first thing we have to check is, are our bases the same? And they are. Both of our bases for this is an x, so we can combine our exponents. So we get x to the 3rd plus 4, which is 7. So we get x to the 7th power as our final answer. Looking at example 5, I encourage you to pause the video and try this one on your own. And now let's work through it together. So the first thing, whenever you have variables and numbers in one problem, you basically, when they're being multiplied or divided, you treat them like separate from one another, but they still all come together in your final answer. So let's first focus on these 3's here. So these 3's, we're going to do 3 divided by 3. So I'm going to write this out. So we're going to do 3 divided by 3. And I'm going to write brackets around this and then use parentheses so I'm very clear about what I'm doing. So we're going to do 3 divided by 3 multiplied by z to the 8th divided by z cubed. So 3 divided by 3 is 1. And then z to the 8th divided by z cubed, remember that's going to use our quotient rule, which means we're going to subtract our exponents. So we're going to do 1 times z to the 8th minus 3. Now 8 minus 3, that is going to be 5, so you're going to get z to the 5th power as your final answer. Now, one thing is that you might notice, well, hey, you dropped this 1 here. And the thing is that you can write the 1 if you want, so you can write 1z to the 5th, but you don't necessarily need to write 1z to the 5th because the 1 is kind of implied. So sometimes if you see a problem where you have, let's say if you just saw z to the 5th, just remember that that also means 1z to the 5th as well. They both are the same thing. They both are the same value. But that is something that you will get more practice with as you go throughout algebra, and it'll start becoming more natural. So looking at example 6, we have y squared all to the quantity raised to the 0 power plus y. So the first thing is we're going to have to use the, well, first off, this one has these rest of these problems have a little bit going on. So the one thing you cannot forget is order of operations, right? So when I say order of operations, remember that's when we use the acronym PEMDAS, right? And if that's something you need to review, I encourage you to go to Unit 4 of this course, or Module 4 of this course, because I talk all about how to solve expressions using order of operations. But once you start going into algebra, order of operations does not go away, even though we're looking at letters versus numbers. Order of operations still is in play here. So with number 6, or example 6, notice that we have to simplify these exponents first before we add this y, or before we look at adding this y. So let's start off there. So we have y squared raised to the 0th power. So we're going to have y squared times 0 plus y. So 2 times 0 is 0, so we're going to go y to the 0th power plus y. Now notice this y to the 0 is equal to 1. Now if you're wondering how does that equal 1, well, remember, if you look at the rules of our exponents, we have this rule called the 0 rule. And this 0 rule tells us that anything raised to the 0th power equals 1. Looking at example 7, I encourage you to pause the video and actually try this one on your own. However, just remember to use order of operations. Use PEMDAS. And assuming you have game to go, let's work through it. So we have 3y squared times 2x cubed minus x squared. So the first thing I'm going to want to do, according to order of operations, is multiply these two terms here together, in which that is correct. So to do that, we're going to first multiply the numbers, or the integers. So I'm just going to write this out so it's very clear in what I'm doing. So I'm going to do 3 times 2. And I'm also going to do y squared times 2x cubed. I'm kind of writing that x as a squiggly x so we can distinguish between an x and multiplication. And then I'm going to add on that negative y squared at the end. So to simplify what we have in brackets here, 3 times 2 is 6, and then y squared times x cubed. Well, notice that this y and this x, these are our bases, but y and x are not the same thing. So we cannot combine these exponents. So this simply becomes 6y squared times x cubed. And then we have that minus y squared. Now here, this is actually going to be our final answer. The reason being is because we have this idea of something called like terms. Now, remember when we were solving linear equations in Unit 6, like terms are the parts of an expression or equation that are separated by addition or subtraction. And if we have any terms with variables or letters that have the same exponent and base, you can add or subtract those terms together. So recall, or look here. If we look here, these are not the same thing, right? So we cannot combine, even though this term here and this term here, they both have a y squared. This term here has a 6. This term here has that x cubed. So moving on to example 8. I encourage you to pause the video and work on this one. And assuming you have given it a go, let's work through it. So first, using order of operations, I am going to focus on dividing these two terms here. So I'm going to first start off by dividing the integers or the numbers. So we're going to do 8 divided by 4, which that is 2. And then I'm going to multiply that by v raised to the 7th minus 0 power. And then I'm going to subtract v to the 6th power. So this is going to get us 2. 7 minus 0 is 7. So we're going to get 2v to the 7th minus v to the 6th power. Oops. And moving on to our last example of this section, we have 2x squared times 4x times 2x to the 7th. Now, as always, please pause the video and just work through this on your own to see if you can get to the correct answer. And now let's work through it together. So, using order of operations, since all we're doing here is multiplying, we're just going to move from left to right. So, starting off, let's focus on these first two here. So we're going to do 2x squared times 4x. So 2 times 4, that is going to be 8. And x squared times x squared times x, so we're going to do x squared times x, and then I'm going to also bring out this 2x to the 7th. So simplifying this 8x squared times x, since we have like bases, this is an x and this is an x, we can add these two exponents together. Now here, this x doesn't necessarily have an exponent, but remember, anything to the first power is just itself, right? So in this case, we're going to have 8x to the 2 plus 1 times 2x to the 7th. So this is going to become 8. 2 plus 1 is 3, so we're going to have 8x cubed times 2x to the 7th. Now we're going to multiply the numbers. So 8 times 2, that is going to be 16. And then multiplying the variables, or multiplying the exponents of the variables because we have the same base, that is going to get That's going to get us x raised to the third power plus 7. It's going to be 16. And then 3 plus 7 is 10. And that is our final answer.